Hello, Math 2. This is Mrs. Bricky, and this video is for lesson 2 of our probability unit, so 11.2. We're going to be talking about conditional probability today. So first, we're going to start with finding some probabilities from a table. So our first set of data is about a company that they have an office in Austin, Texas, and an office in Copenhagen, Denmark. The company wants to know about how their employees are getting to work, so they take a survey of all their employees, and they've summarized the results in this table. So you can see some of them walk, some take a car, public transportation, or bike. So on your paper, there's 6 questions to read through, and just see if you can answer those. Probably good to pause the video and look at those for a second. If you can. So let's look through what the answer to each of these are. So our first question is, if an employee is selected at random, what's the probability that they work in Austin and drive a car to work? So we're interested in that the people who work in Austin and they drive. So the ones who work in Austin and drive a car to work, those are right here, 376 employees in that category. So that's going to be the numerator of our probability fraction. And then the denominator would be the sample space, all of the people. So here we go, 1104. Now that fraction can definitely reduce. With probabilities, we can either report our answer in fraction form or in decimal form or in percent form. For this example, I'm just going to leave those fractions the way they are. Definitely this one could be simplified if you wanted to punch it into a calculator, but I'm just going to leave them like this for this example. So the second question says, if an employee is selected at random, what is the probability that they work in Copenhagen and ride a bike to work? So we're now interested in the people who live in Copenhagen and ride their bike. So there's 276 of them. So 276 out of the 1,104 employees. And again, not going to reduce that fraction. Oh, sorry, I did a little transposition there. Sorry, that should be 267. 267. Okay, so our next question says, if an employee is selected at random, what is the probability that they take a public transportation or public transit to work? So the question is, how, what's the probability that an employee employee selected at random, what's the probability they take public transport? So this one isn't specifying which city they live in. So it would include all of the employees who take public transit. So that would be 220 out of 1,104. We're just selecting an employee at random. All right, this one says, if an employee from Copenhagen is selected at random, what is the probability that they ride a bike to work? So this time we're only thinking about employees from Copenhagen. So we don't want to think about any of those employees who are in Austin. We are only thinking about the ones in Copenhagen. So there are, if we're looking for the ones that ride bike, 267. But this time, it's not out of all 1,104 because we aren't thinking about the ones in Austin. We are only thinking about the Copenhagen employees. We know that they're in Copenhagen, so it's only out of 477. And our final question is, if an employee who takes public transit to work is selected at random, what is the probability that they work in Austin? So let's see. We're right now interested in employees or thinking about employees that take public transit to work. We're going to select one of those at random. What's the probability that they work in Austin? Well, 125 of them work in Austin, and there are 220 who take public transit. So 125 out of 220. So our last question says, how are the last 2 questions different from the first 3? And I hope you noticed that they are not out of the whole group anymore. They're only out of a subset of the group. On part D, we were only interested in the employees from Copenhagen. In part E, we were only interested in the employees who take public transit. So we were no longer out of the whole group of 1104. We were out of a subset of a group. And that is what our focus is going to be on today. Today, we're going to be learning about conditional probability. So conditional probability is the likelihood of an event occurring based on the occurrence of a previous event. In other words, event A has already happened, and now what is the chance of event B? Notationally, we use a vertical bar to symbolize conditional probability. So if we have the conditional probability of B given A, it's written like this. It's like the probability of B, and then we have a bar and the A. And so when we read it, the bar is read as the word given. So if I was reading that little highlighted probability right there, it's the probability of B given A. When we're talking about conditional probability, order matters. So the conditional probability of B given A is different from the probability of A given B. So you have to think about which one is the given. And the given, conditional probabilities are giving the likelihood of an event occurring based on the occurrence of a previous event. So when we're calculating conditional probabilities, the denominator is limited based on the condition. It's not out of the whole group. It's out of a subset of the group, the portion of the sample space that fulfills that given condition. So if I'm just going to go back one slide. If I was writing question D in conditional probability notation, I would say, what is the probability that they ride a bike given that they're from Copenhagen? And if I was writing question E in conditional probability notation, it would be, what is the probability that they work in Austin? And the given is that they take public transit to work. So the thing that comes after the bar is the condition. It's the thing that is known to be true or known to have already occurred. And the probability that you're calculating, that's what comes first. I want to know the probability they work in Austin. The thing that I know is that they take public transportation. Okay, so let's try a couple. Here's a new table. This table summarizes data from a survey of 200 people who reported their home environment, either urban or rural, and their pet preference, dog or cat. So they were just asked, which of these two things fits your preference or your home environment. So we're going to calculate some probabilities. The first one is the probability that they live in an urban environment given that they prefer cats. So again, the given condition comes second. So we know that these people prefer cats. So we're only thinking about this cat category. And so we want to know the probability within that category. We know that they prefer cats. We want to know the probability that they live in an urban environment. And you can see that it's going to be out of the 96 people who preferred cats. And there were 54 of them right here that lived in that urban environment. For this example, I'm going to convert everything into a percentage. So just to, kind of practice all of the different types. So in my calculator, if I divide 54 by 96, it gives me the decimal 0.56, which is the same as 56%. So 56% of people live in an urban environment given that they prefer cats. Okay, let's try this one. It's also the probability of living in an urban environment, but this time the given condition is that they prefer dogs. So I'm only thinking about the group of people who prefer dogs, not the whole group, not the cat people, just the dog people. So this is going to be out of 104. And you can see that those who live in an urban environment total 80. So this is 80 out of 104. And if we calculate that as a percentage, in your calculator, you can do 80 divided by 104. That gives you the decimal 0.77, so that is 77%. Okay, I talked about a second ago that order matters. So you can see we just did the probability that they live in an urban environment given that they prefer dogs, but now we're going to do the reverse of that. What is the probability that they prefer dogs given that they live in an urban environment? So this time we are not limiting ourselves to the group of people who prefer dogs. We are limiting ourselves to the people who live in an urban environment. That's our focus group. That's our condition. We know that they live in an urban environment. So it's going to be out of a total of 134. And how many of those prefer dogs? Well, that would be 80. And you'll notice these two things the one we just did and the one we did now, they both have that 80 in the numerator, but the conditional group, the subset of the sample space that they're out of is different. Okay, so we have 80 out of 134. If we calculate the percentage, that would be 60%. So it's more likely that they live in an urban environment given that they prefer dogs than that they prefer dogs given that they're in an urban environment. Okay, let's do one more conditional probability here. We want to know the conditional probability that they prefer cats given that they live in a rural environment. So this will be focusing on this condition. We know it is known that they live in a rural environment. So our fraction here is going to be out of 66, and those that prefer cats, number 42. So 42 divided by 66 gives us 64%. Okay, our last one is not a conditional probability. You have to be sort of used to the notation and get used to noticing when things are conditional and when they are not. If it says the probability that they prefer a cat and they live in a rural environment, none of those things are known. That's just going to be out of the whole total of 200. And those who prefer cats and live in a rural environment, our numerator is going to be 42. So this is not conditional. It doesn't have that bar that tells us it's conditional. So that would be 21%. Okay, so on this example, I gave you all of these little notation things that told you what to find, but oftentimes you'll be given questions that's just worded. What is the probability that a randomly selected student travels via car given that they're in 10th grade? And there's a lot of different ways that the wording can go. So what we're going to do on this example is practice reading the sentence and converting that into the notation to help us find the probabilities. So focusing on figuring out what part of it is given and which part of it is the probability that we're calculating. So the information here is about a school district that did a survey of how their students are getting to school. So we've got grades 9 through 12. We have car, bus, walk, and so that's what we're going to be using for our probabilities here. So the first one, what is the probability that a randomly selected student travels via car given that they are in 10th grade? So this one, the wording is really friendly. It literally says given, so we are a little bit less, it's a little bit less difficult to identify. So the given information is that they're in grade 10. We know that they're a 10th grader. So that tells us which subgroup that we are focused on. So we know that our probability is going to be out of 3,218, and we want the probability that they travel via car. So the probability they travel via car, given that they're in 10th grade, here's the number for cars, 1126. And for this example, let's just go ahead and leave them in fraction form so that we can go through them a little bit faster. Obviously, you could type them in and reduce them if you wanted to. Okay, the next one. If a grade 10 student is selected at random, what is the probability that they walk to school? So it doesn't use the word given in this sentence, so we have to interpret it. but we are selecting a grade 10 student. We know that they are in grade 10. So this is the same condition as the question above. It's just worded a little bit differently. So we are, again, out of 3,218, and we're focusing still on that grade 10 group. So our question is, what is the probability that they walk to school given that they are a 10th grader? So you can see there are 322 of the 10th graders who walk to school. So our fraction is 322 out of 3,218. Okay, we've got a couple more focused on this data set. So this next question says, what is the probability that a grade 12 student rides a bus to school? So we know that we are focused on a grade 12 student. What is the probability that a grade 12 student walks to school? We know they are in 12th grade. That is known. The probability that we want to calculate is that what's the probability that they ride the bus to school? So our 12th graders number 2,234. So this is going to be out of 2,234. And the number that ride the bus is 447. So there is our probability. And again, we could easily convert this into a decimal or a percent if we wanted to, but we'll just leave it for now. Okay, so next one, last one of this example. If a student who rides the bus to school is selected at random, what is the probability that they are in grade 12? So our probability is that they're in grade 12. Our given information is that we are limited to thinking about the students who ride the bus to school. So it's going to be out of, that's our given, they ride the bus. It's going to be out of 6,212. And we need to think about how many of those students who ride the bus are 12th graders. Well, there are 447 12th graders who ride the bus to school. So these two have the same numerator, these two examples that are on the screen right now. But because their denominators are different, their probabilities are a lot different. So if I calculate that first one as a percentage, this is 20%. So if I look at all the 12th graders, 20% of them ride the bus. But if instead, in part D, I'm thinking about all of the students who ride the bus, this is only 7%. 7% of the students who ride the bus are seniors. So, that order of the conditional probability matters. It can make a pretty big difference in your answers. Okay. All right. So now we are going to do 3 more examples with conditional probability, but this time we do not have a table. We just have some information, and the information is maybe incomplete. We don't have every single number given to us. We might have to calculate some of the quantities. So this first one, we've got a table kind of set up ready to go for us, and then in the next one, we'll practice setting up a table. We do just have one question to answer, and the question this time is, if one student is chosen at random, find the probability that the student is in band if it is known that they are not an athlete. So we also have this not to think about and consider. Okay, so our scenario is we have 30 students in Mr. Smith's math class, 30 students total. So I'm going to put grand total 30 right there. We know that 13 of them are athletes. So I have athletes and not athlete across the top. So if for any given student, they either are or are not an athlete. So we know that there are 13 total athletes. And then we know that there are 9 students that are in band. So that's the total for band. The next sentence tells us that 3 of the athletes are also in band. So that would go in this box. We know that 3 of the students who are athletes are also in band. Well, that means 10 of them are not in band. So you can do a little bit of subtraction. Let me change the color on that. So I can do a little bit of subtraction to figure out some of the other information. So since the total of the athletes is 13 and 3 of them are in band, we know that there are 10 that are not in band. We know that there are 9 band students in total. Since 3 of them are athletes, that means 6 of them are not athletes. And you can use a little bit of addition or subtraction to figure out all of the other numbers in this table. We have 30 total students, 9 of them are in band. That means 21 of them are not in band. We have 30 students in total, 13 of them are athletes. That means there are 17 that are not athletes. And then our last number here would be 11. So now we have this complete information that we can use to answer our question. The question is, if a student is chosen at random, find the probability that the student is in band if it is known or given that they are not an athlete. So this is, we want it, it's going to be out of, the condition that we know is that they're not an athlete. So it's going to be out of 17 students. And how many of those are in band? Well, there are 6 of them. So our probability is 6 out of 17. That's about 35%. Okay, let's try another one. This one tells us there are 62 people taking yoga and 48 people taking a spin class at the gym. 15 of the people that take yoga also take spin, and if a person from these groups is selected at random, what is the probability that they are taking yoga if you know that they take the spin class? So sometimes, especially once you've practiced conditional probability, sometimes you can answer questions like these without working on or filling in a table, but I'm going to use a table just to help us organize our thinking and our information and help us to get to that answer. So we have to figure out, I don't have any categories written on this table, so we have to figure out how to categorize this. Now, a mistake that sometimes people make is that they'll be, reading this information and they'll think, okay, yoga, spin. But that is not going to work because a person can be in yoga and not in spin, or they can be in spin and not in yoga, or they can be in both, or in theory, they could also be in neither. So these are not like mutually exclusive groups. So a lot of times, but not always, what your categories are going to be is like athlete and not athlete, band and not band. And in a second, we'll do an example where it's not that way, but that's often how the categories go because you're either in yoga or you're not in yoga. So that's going to break the group into the total group into those 2 categories. So we're going to do yoga and not in yoga, spin and not in spin. And you can use our not symbol if you want. That will work. So you can use the squiggle for the word not, or you can use the word not, whichever you prefer. Okay, so we know that there are 62 people taking yoga. That's the yoga total. And we know there are 48 people taking spin. That's the spin total. And so the other information we have is that 15 people that take yoga also take spin. So this would be the overlap, the people who are in both classes. So we have these numbers given to us, and so we could calculate some of these other categories if we wanted. So for example, if there's 15 people in yoga and spin, that means there are 33 right here that are in the spin class but not taking yoga. And if there are 62 total student or people in yoga, but 15 of them are in spin, that leaves 47 that are not in spin. Okay, now interestingly, in this particular example, I don't actually have enough information to fill in these other numbers, but luckily I don't need to. So these are just unknown. We don't have a grand total. We don't have any other subtotals. So we can't calculate those numbers. All right, so what we need though is a probability. We need the probability that they're taking yoga if you know that they are taking a spin class. So we know that it is going to only be out of those people taking spin. So we're focused on this category or this subgroup right here. So it's going to be out of 48. And how many of those are in yoga? Well, there are 15 of them, 15 out of 48. So that's about 31%. Okay, this is our last example. Example 5, a total of 200 students for the 11th and 12th grade took a survey to determine whether they plan to attend college or start a career in the fall after graduation. 60 of the 11th grade students responded that they plan to attend college, and then 104 12th grade students were surveyed, and 26 of them stated that they were planning to start a career. So first, we're going to try to get all that information into a table. So we don't have, in this case, like a situation where we can do athlete and not athlete. But we do have our data broken into these mutually exclusive categories. Like if we know there's a total of 200 students, and those students are either in 11th grade or 12th grade. So the grade level is one of our category breakdowns. The survey only included 11th or 12th graders. So they're either in 11th grade or they're in 12th grade. They can't be in both grades. So those are two mutually exclusive categories. They're also asked whether they plan to attend college or start a career. So they have to pick one of those. And going to college doesn't mean you don't have a job. It's just the students were choosing between, are you going to be attending school or are you just going to be working? So those are also mutually exclusive categories. So this next sentence right here says 60 of the 11th grade students responded that they plan to attend college. So 60 of the 11th grade students plan to attend college. Okay, next sentence says 104 12th grade students were surveyed. So that gives me the total of the 12th grade students. And 26 of them, so that's 26 of the 12th grade students, stated that they were planning to start a career. So 26 goes here. All right, so let's see if we can figure out the other numbers in the table. So we know if there's 104 12th graders, we can subtract from 200 to get the number of 11th graders in the survey. So that's a 96. And to get the career bound 11th graders, we can take that 96 and subtract 60 to get 36. We also now can get the total of the career category. So we can add together the 36 and the 26 to get 62. And we can subtract 104 minus 26 to get the number of 12th graders that are planning to go to college. And then finally, we can add together. And obviously, there's more than one path to the answer, to filling in the table here. But just use addition and subtraction to figure out the numbers in all of those boxes. Okay, we have two final probabilities to calculate. Determine the probability that an 11th grader plans to start a career. So we're thinking about 11th graders here. That's our given condition. Determine the probability that an 11th grader plans to start a career. So we're trying to find the probability of a career given 11th grade. So this is going to be out of our 96 11th grade students, and there are 36 of them who plan to start a career. So that is 37.5% or 0.375. Next question, last question. Determine the probability that a student who plans to attend college is an 11th grader. So a student who plans to attend college, that's our given. And we want to know the probability that one of those students is a 12th grader, a senior. So this is going to be out of 138. And of those 138 who are planning to go to college, 78 of them are seniors. And so this gives us the decimal 0.565, so 56%, 57%. All right, that's it. That is conditional probability. Please let me or your teacher know if you have any questions about conditional probability, and thanks a lot.